Welcome to the Science of Sports Performance, where we discuss the real science of nutrition and exercise, helping you train smarter, fuel better, and perform at your very best. My name is Ben Pressler, and I'm currently an undergraduate student at Brigham Young University, majoring in both nutritional and exercise sciences. I'm pursuing my PhD with a goal of becoming a professor of sports nutrition. Today, we are going to be talking about the artificial sweetener sucralose, specifically answering the question of whether or not it causes an insulin spike in the body. Now, I recorded this video yesterday, and as you'll soon see as we get into the content of today's episode, I do have a lot of graphics and slides, I guess, to go along with the presentation today. I actually planned on making this episode sort of a YouTube special. I really just thought it was going to be a 10 or 12 minute video going over some papers as well as a study that I actually conducted on myself to see if sucralose causes an insulin spike. And so I have all those graphs for you. I do recommend that you watch this episode on YouTube so that you can see the video along with it. However, at the end of my recording session yesterday, I just got myself going, and it turned out to be a 30-something minute conversation that I had about this artificial sweetener sucralose. So for that reason, I decided that it would be appropriate to make this a bonus episode of the podcast and upload it to all of the podcast audio-only platforms where I publish. Again, I do recommend you watch this on YouTube, but I hope you enjoyed today's episode, that you learned something. Let's get into sucralose. Today, I wanted to do sort of a special edition episode, just YouTube style, not a podcast, because I just finished a little miniature study that I did on myself. It was just something fun that I wanted to do because, I'm a nerd for nutrition and exercise physiology. And, actually, with this study, where it came from was because I had this coworker, an old coworker of mine who was super, I don't want to say afraid, but very cautious of the amount of kind of food additives and, ingredients that you can't pronounce the name of in his food and his, drinks and all these different things. And I don't think he understands what most of these things mean, but he's very, very concerned of them. And, one day at work, I was drinking a Gatorade Zero Sugar. And I love zero sugar drinks like, zero sugar Gatorade. I love diet sodas because, they satisfy my sweet tooth without contributing any calories to my diet, which is something that I find very appealing. And, he immediately began to say, well, that's terrible for you. It's this bad drink because it has these artificial food colorings and these artificial sweeteners. And we got onto the topic of sucralose, because sucralose is the primary artificial sweetener used in this Gatorade Zero Sugar. And so he started telling me that, Gatorade Zero Sugar, sucralose will signal to your body to have an insulin response, which is something that I had heard before, but I think is kind of unfounded. He said, that's terrible for you. It's going to lead to you developing type 2 diabetes because you're drinking, this sucralose-containing beverage, sucralose-sweetened beverage. It's going to cause your insulin to spike, and you're going to develop type 2 diabetes. Now, first of all, we could break down that whole statement, right? Is an insulin spike in and of itself going to lead to type 2 diabetes? And the answer is no. That's how our bodies are designed to handle. When you eat a meal, when you fuel your body for exercise or even just for normal life, when you consume carbohydrates in a meal, your body releases insulin. You're going to have an insulin spike. You're going to have a blood glucose spike from that meal. And that in and of itself is not going to cause type 2 diabetes. That's what your body is designed to do. A really good way to kind of compare it to is a thermostat, right? So if say it's wintertime, you have the heater set to a certain temperature that you want to keep your house. When it dips below that temperature, it gets a little colder in your house, your thermostat kicks on, and it starts warming your house until it gets to that temperature that you've set it to. And that's totally fine. That's normal. That's what it's supposed to do, right? Your thermostat just kicks on for a little while to get your house to the temperature that you want to be. And that's exactly what your pancreas does for insulin. Your blood glucose gets a little high. your pancreas is going to release some insulin to take it down to baseline where it's supposed to be. What happens, the issue that arises is, say the thermostat example is when you leave the front door open in the freezing cold winter. Then, your thermostat's going to kick on and it's just going to have to keep working and working and working, and it's never going to get your house to that temperature that you want it to be. It's just running nonstop. And that is going to be the issue with, developing type 2 diabetes, is when you eat and you eat and you eat and you eat. Especially it arises when, your cells are kind of already full of all of the, glycogen and, the glucose that they'd like to have. They're kind of full, and so it takes more insulin to convince them to, open up those glucose transporters to take that glucose into the cell. And, after that repeats itself, just like leaving your door open in the wintertime. That is going to be the issue that arises that could lead to things like type 2 diabetes. So really breaking that down, first of all, I didn't think that sucralose really did elicit an insulin response. And secondly, if it did, does it really matter? But anyways, this coworker of mine who brought this to my attention, and we were having this little bit of a debate about sucralose. He is not the kind of guy who really cared to hash out over the science and the studies that have been done already. That's exactly what I like to do, and I'm trying to learn is look at what science has been conducted and the studies that have been done already and refer back to them. But he kind of seemed to be a little stuck in his ways and, probably would find some reasons why he didn't care for the results of these studies and so on. So, being the nerd for nutrition that I am, I said, all right, let's do it. Now, mind you, I work as an EMT firefighter. The coworker that I had, who we started this conversation about, he was a paramedic. I was an EMT, and one of the things that we carry on all of our ambulances are glucometers, devices that we use to measure somebody's blood glucose levels. And the reason for that is because your blood glucose can cause a huge range of medical problems, whether that's simply passing out, whether that's diabetic ketoacidosis. Can actually cause seizures if you are hypoglycemic or low blood sugar. And so that's a very, very common thing that I do as an EMT is to take blood glucose level tests. So it's something I'm very familiar with, very comfortable with. You could almost call me a blood glucose level taker professional. And so, understanding that is something that he was familiar with as well, I said, let's test it out. Let's try it. Let's set up an experiment, and I'll show it. I'll show you. I'll prove it. I'll prove you wrong through science. And so I set up this study, trying to figure out whether it was really going to affect my insulin and my blood glucose to consume sucralose. And I have now finished this study, and I want to share it with you guys today. So it is the insulin response from sucralose sweetened beverages by Ben Pressler. Now, I wrote this kind of science-y just because I don't know, that's how I read about science. It felt fitting to write about science this way, but I'll kind of let my hair down and talk about it more casually with you. So the objective of this research is that it is thought by some individuals that artificial sweeteners, namely sucralose, though calorie-free, send a signal to the body to release insulin upon ingestion. Of course, some individuals mainly refers to this coworker of mine, but like I said, it's something that I've heard before on social media and from various people. So it's true. It is thought by some individuals that there could be, harms to consuming sucralose. I go on to say this may be of concern to certain individuals with pancreatic or glycemic illnesses. This experiment was designed to test whether or not the artificial sweetener sucralose causes an insulin response, as interpreted by blood glucose measurement. For this study, one male, age 22, that's myself. I'm actually 23 now, but I was 22 at this time, free of pancreatic or glycemic illnesses, would be tested to determine if the effect of sucralose on blood glucose level, or BGL, as you will see it written in this paper, and thereby determine whether or not it causes an insulin response. The male would be given 40 fluid ounces of sucralose-sweetened electrolyte beverages. That is 540 milligrams of sodium and 160 milligrams of potassium. And what that is 2 bottles of Gatorade Zero. So yeah, the same drink that he was telling me was so bad for me, I wanted to take 2 of them to really kind of exaggerate any effects that might take place and see what effect it was going to have on my blood glucose level. The study would be conducted over 2 separate days, where on the first day, the participant, me, would drink a controlled drink of 40 fluid ounces of water with the same electrolyte content as the sucralose sweetened beverage, which you will see as SSB in the remainder of this paper. And have his blood glucose measured. The glucometer we use uses milligrams per deciliter. The sucralose sweetened beverage would then be consumed on the second day, blood glucose levels measured, and the value obtained after drinking each beverage would be compared. The test would be conducted approximately 11 a.m. each day after the subject fasted overnight, duration of approximately 15 hours. What does that put me at? I think I stopped eating the night before at then 8 p.m. So a fast, so that there should not really be any other things affecting my blood glucose levels aside from the drinks that I would be having. The test would be conducted at this time because cortisol levels are highest in the beginning hours of the day, and cortisol is known to affect blood glucose levels. A baseline blood glucose level would be attained at time t equals 0, followed by a second measurement at time t equals 20 minutes to determine whether the body was naturally altering blood glucose levels. After the second measurement at time t equals 20, the beverage would be consumed and blood glucose levels measured at time t equals 40 minutes, and finally at time t equals 60 minutes. The purpose of the control beverage is to determine whether any change in blood glucose level may be caused by an increase in blood volume due to the ingestion of water and electrolytes. Each blood glucose level test would be conducted with a blood sample obtained by finger prick with a lancet. The first drop of blood would be wiped away with gauze, and subsequently 4 drops of blood would be tested on one each blood glucose level testing strips read by a glucometer. Now, that is kind of standard protocol to test your blood glucose, is to prick your finger and wipe away that first drop of blood. The reason for that is because that first drop of blood could just kind of have, the contents of some of your skin cells or vascular cells that have been destroyed by means of the finger prick. So we usually take that good first drop of blood, wipe it away, and then test the second one. On an ambulance, and in my line of work where I am taking these blood glucose tests, it's not common to take 4 separate tests. It's not at all. Usually you just take one and then you call it good. You'll see here, you can actually already kind of see at the bottom of the screen that they're fairly consistent. They vary probably 4 to 6 milligrams per deciliter in their range. So usually, for the purpose of seeing whether somebody is drastically low in their blood sugar or drastically high, one is plenty on an ambulance. However, they're not perfectly accurate, as you will see. And so I wanted to take 4 different tests and then average those values just so that there really could be no excuse for why. I just wanted to be very, very accurate, basically. Anyways, the glucometer that I use has an accuracy rating as follows, according to its manual: 88% of readings within 10% of the true value, and 100% of readings within 15% of the true value when readings are above 75 milligrams per deciliter. The 4 values obtained at each time would be averaged and recorded. The trend in blood glucose levels response over time would be compared between both beverages. Because sucralose has no calories, if it were to signal an insulin response in the body, we would expect to see a drop in blood glucose level at time t equals 40 and or 60 relative to the control beverage. Now let's pause right here. What is sucralose? Well, sucrose, of course those names are very similar. Sucrose is table sugar. It is called a disaccharide, meaning it is 2 saccharide molecules combined with each other. And in this case, those 2 saccharide molecules are glucose and fructose. So it is a glucose, which is a monosaccharide, and fructose, which is a different monosaccharide, formed together into a disaccharide, or just saccharide is a fancy word for, chemical name for sugars, and it makes sucrose. Now, sucrose, on the chemical structure, I think I'll find one and put it up on the screen for you guys here. It has these groups called hydroxyls, which is an oxygen and a hydrogen, written OH. And in sucrose, a few of those hydroxyl groups are replaced with the word slipping my mind. It's replaced with a chlorine or a chloride. And because of that, it makes the body unable to metabolize that sucralose, and somehow it makes it way sweeter to the tongue than sucrose. That's common with many artificial sweeteners, is that they are 100 to sometimes 1,000 times sweeter than sucrose is. And sucralose, in this case, I think it's about 600 times sweeter, which makes it a great artificial sweetener. Aspartame is a good example. Aspartame is actually a dipeptide, which means it is composed of 2 amino acids. It is aspartic acid and phenylalanine. And then it has a menthol component as well, I believe, to it, or methanol component to it. But so it is actually calorie containing because it's a protein. So it would have 4 calories per gram, just like a sugar or a carbohydrate would. However, it is so much sweeter than sucrose that you don't need to put very much of it into a drink at all. I think, aspartame is primarily found in diet sodas, and I think they only put like 200 milligrams of aspartame into each can of diet soda, which is, less than 1 calorie, I believe, of aspartame. So effectively, diet soda containing aspartame is 0 calorie. So that is sucralose. So sucralose, however, really is, metabolically inert is the fancy word for it, which just means that our body doesn't break it down at all. It really is pretty much calorie-free. So again, if you didn't understand what I'm saying, the thinking is that it's not actually going to raise your blood glucose level because your body's not going to be able to produce glucose from the digestion of it because it can't digest it. However, if it was true that it would raise your insulin, it would, elicit an insulin response from your pancreas, then that insulin would actually lower your blood glucose because the sucralose would not raise your blood glucose. So if it's true that sucralose does make your body release insulin, we would expect to see a lowering of the blood glucose level. These were my results. You can see in this table here, at time t equals 0 for the control beverage, I started at 88 milligrams per deciliter. Time t equals 20 for, this control beverage that was just water and electrolytes. 96, so it went up a fair amount, which I really don't have good explanation for you as to why. But then it stayed about the same at 95.75 and then dropped down at time t equals 60 to 84.5. Again, presumably because that 40 fluid ounces of water that I consumed along with those electrolytes increased my blood volume. So it increased the amount of deciliters of blood. And so the glucose stayed, about the same in absolute content. However, because there's more blood volume, the glucose per unit volume of blood went down. The sucralose beverage, I started at 90 milligrams per deciliter, went up to, 96, which is exactly the same, which I thought was cool. Then it goes down to 90 at time t equals 40, and at time 60, 82.75. Now, you might already notice it actually did kind of decrease, but obviously, let's just go ahead and show you the graph here. It's always easier to visualize things with a graph. So this red line was my control beverage, just the water, and the blue line was the sucralose beverage. They're shown here with a 90% confidence interval. Those are these bars here that you'll see. So again, I started at, upper 80s, went up to 96, stayed about the same, and then came down at time equals 60 with the control beverage. And then the sucralose beverage, I started a little higher, ended up getting about the same, exactly the same at time 20, and then it went down starkly compared to the control beverage. So that would mean that if my blood glucose level is coming down, it would mean that the sucralose signaled to my body to release insulin. So far, it seems like that might actually be the case. What we're looking at is kind of the area under the curve, right? The area under the curve would be representative of the amount of glucose in my blood. And so since there is less area under the curve, there's less glucose in my blood, there was more insulin released. Now, I've shown the 90% confidence interval, which I calculated based off of the values that I got. So for example, this time t equals 0 for the control beverage was 88, but it was actually an average of 93, 88, 83, and 88, which is actually super easy math and, takes you to 88 pretty easily. But so depending, not all those were quite as simple, and some were far and some were close. And so I calculated the confidence interval, which basically means how confident are we that the true value is within this range, or it is this number. And so we are 90% confident that the true value is within that range. So let's look at this one right here. At time t equals 40 for the sucralose beverage, the value is, looks like about 90. I don't remember off the top of my head without looking. It was 90. There we go. And with 90% confidence, we can say that it truly was between about 93 and 87, let's say. So we do feel like it was somewhere in there. Now, what you'll see on these is that their 90% confidence intervals actually overlap on every single one of them. Time t equals 20 is probably going to be the most, indicative because they were the exact same measurement. But look, we're 90% confident that it's somewhere within here for both of them. Maybe this is a better example at time t equals 40. It could, for this blue number, be somewhere right in here, and for this red, it could be somewhere right in here. So there's a good chance, that they're not the same, but there is a small chance that they could be the same value. Now, if you're familiar with statistics, if you're familiar with these scientific articles, p-value is kind of what we really want to look at to see if something is different. What the p-value says is, what is the probability that you would be able to replicate these results if the results were obtained by random chance? The results aren't actually accurate or anything. They're not actually indicative of what would really happen. It was just the luck of the draw that that's what happened that day. What is the probability you'd be able to repeat them? The gold standard is 0.05, which means that there is only a 5% chance you'd be able to replicate these values if it was obtained by random chance. So the smaller the p-value, the smaller chance it is that these were a random value. Now, let's go ahead and move on. The difference in average blood glucose level between the control beverage and the sucralose sweetened beverage were, at time t equals 0, minus 2 milligrams per deciliter, time t equals 20, 0 milligrams per deciliter, time equals 40, 5.75 milligrams per deciliter, and at time t equals 60, 1.75 milligrams per deciliter. Since times 0 and 20 minutes were not affected by the beverage intake, we can exclude them as we consider the effects of sucralose on blood glucose level and insulin response. The p-value associated with the difference at time t equals 40 minutes is p equals 0.025, meaning the difference is statistically significant. The p-value associated with the difference at t equals 60 minutes is p equals 0.547, which does mean this is not this is not a statistically significant difference. Again, going back, at this difference at time t equals 60 minutes mean that there is a 54.7% chance that we could replicate the results of this study if it was just totally random, which means that there's a good chance it was totally random. Now, the 90% confidence intervals for the two beverages overlap with each other at all time intervals. Now, that is curious, though, that, obviously it was a bigger difference at this time, t equals 40, than it was at 60, but we see then that there was a statistically significant difference, even though, we see here that the 90% confidence intervals overlap. These were statistically significant. The statistics show us that sucralose did have some kind of effect on my blood glucose level, presumably through insulin. As a man of science, even though, I didn't think that sucralose was going to have any effect, I'm being shown by my own data that it did have a difference. Now, let's look at these conclusions. What do we draw from this data? Because again, if the question to you is simply, does sucralose affect your blood glucose level? Does it perhaps, elicit an insulin response in your body? So far, this little study that I did on myself says yes, it does. However, the question really, we don't care if it does release insulin. We care if that insulin response affects our health. That's the real thing that we want to know and learn. And so we can see from the data that the difference in blood glucose level between the control and sucralose sweetened beverages are significantly different at time t equals 40 minutes. However, the absolute difference is relatively small, meaning that the difference, though significant, is likely of very little concern for those trying to manage glycemic or pancreatic illnesses. The effect of blood glucose level of a meal with high glycemic load, in this case in the study, glycemic load of 42, has been shown to raise blood glucose level by 2 millimoles per liter, which is about 36 milligrams per deciliter, in a similar time frame to this study. The difference in blood glucose level from ingestion, T equals 20 minutes, to time equals 60 minutes of the sucralose sweetened beverage was only 1.75 milligrams per deciliter less than the change caused by the control drink. Additionally, drinking 40 fluid ounces of sucralose sweetened beverage in a time of only 1 to 2 minutes, as I did for this study, is very uncommon, which would make the results found in this study exaggerated beyond what would happen in response to normal consumption. Again, I drank 2 bottles of Gatorade Zero pretty much just as quickly as I could at that time T equals 20 after I got my blood glucose level taken. Usually, someone who's going to have something like this is probably going to have 1, and they're going to kind of sip on it for, probably 10 minutes at least, right? And then maybe even up to an hour. And so this really should be probably exaggerated to the response most people are going to get from drinking these sucralose sweetened beverages. Now, those with illnesses requiring the monitoring of blood glucose level who wish to optimize every area of their pancreatic or metabolic health may consider the findings of this study and limit sucralose intake. But the American Diabetes Association's nutrition guidelines, including a focus on non-starchy vegetables, lean proteins, whole grains, and avoiding added sugars and processed foods, are likely to be of a much greater consequence than avoiding sucralose-sweetened beverages. Sucralose-sweetened beverages may be especially advantageous to those who habitually drink sucrose-sweetened beverages when it comes to glycemic control. Now, that was sucrose-sweetened beverages, full-calorie, full-sugar beverages, because we know that the glucose response to sucrose is going to far outweigh that of sucralose. Now, the limitations of this study, I think, are pretty obvious. Ready? The obvious limitation of this study is that it was conducted on a sample size of 1 person, just me. This could mean that the conclusions are results of various epigenetic causes, and that other individuals may elicit different blood glucose response or blood glucose level responses to a sucralose consumption than the male in this trial. Another limitation is the very fact that this study interpreted the insulin response of sucralose-sweetened beverages by means of blood glucose level as a proxy measurement due to budgetary and equipment restraints. The best way to evaluate whether sucralose-sweetened beverages cause an insulin response in the body is by measuring serum insulin. It may also have been appropriate to have the subject ingest a positive control beverage sweetened with sucrose to compare the effect of blood glucose level to that of sucralose-sweetened beverages. So that would mean me drinking 40 fluid ounces of full sugar normal Gatorade. The reason I didn't do that is because I don't really like consuming liquid calories, and I didn't want to consume 400 or 500 calories, whatever it is, in my day just from Gatorade. But it would have been interesting to see what would have happened. To better understand the effect on insulin and blood glucose level, more trials should be conducted on a larger subject population with more controls and better equipment. Nevertheless, this trial provides interesting information on the body's response to sucralose-sweetened beverages. And here are my citations. Now, I hope you guys found that kind of interesting. It's fun that, I kind of get to do this own little research and science on my own. But let's look at what, does the actual science say, the peer-reviewed literature that makes it into journals. This one is never going to make it into a journal, right? Because it's just me being goofy in my bedroom with a glucometer. Now, let's look at this. This is actually one of the studies that I cited. It's the inverse association between the effect of carbohydrates on blood glucose and subsequent short-term food intake in young men. Now, the goal of this study was actually to kind of see whether they gave young men in this study drink sweetened with a variety of different starches and sugars, and they wanted to see how that affected their blood glucose levels, and then how that the difference in blood glucose changes from these drinks, whether that affected their hunger later. Now, for the purpose of this, I don't care so much about whether it did affect their subsequent hunger. I mean, that's a separate conversation, right? You'll hear from certain people, that artificial sweeteners are bad because they make you crave more sweet things and go out and seek calories in other ways. Personally, anecdotally, I've never noticed that. For me, my diet sodas and things satisfy my cravings, and I feel just fine. I love them. They're a great tool to help me stick to my diet. But anyways, what I care about is one of the figures, and here it is right here. What they did is they measured the area under the curve, that's AUC, for blood glucose in millimoles per minute, or millimole minutes per liter. Now, you look at this here: sucralose, fructose glucose, sucrose, polyglucose, and plain glucose. And so you can see, going over here, as we head on this side of the graph, these things affected the blood glucose in a huge, huge way. This is the reason I cited this study as part of that one is look at glucose here. It affected their area under the curve to almost 200 here, whereas sucralose, what does it look like? 10, a figure of 10. So the sucralose, compared to the glucose, or compare it to the sucrose even, which is, what traditional Gatorade is going to be sweetened with. Well, I think real Gatorade uses a combination of sucrose and glucose. They call the glucose dextrose. That's kind of the food name for glucose, is dextrose. And that's really what our body likes. Sucrose contains fructose in it. So just plain glucose is probably going to be, speedier for your body to utilize that as energy, which is, something that's desirable in Gatorade. Sucralose really did not affect the blood sugar very, very much. Now, another one, which is actually one that this study cited, another study, actually, it was from a line in this study that basically said something like sucralose does not affect the body in a glycemic manner, or something like that. And this is the study that decided to say that. Ready? This is the last thing we'll go over, and then it'll be done. Thank you, guys. This says the glycemic effect of a single high oral dose of the novel sweetener sucralose in patients with diabetes. Yeah, they addressed that patients with diabetes might want to seek after these things like artificial sweeteners, and they wanted to address whether or not sucralose was going to, be one of those things that they needed to be concerned about. So, the present study examined the effect of a single high oral dose of sucralose on short-term glycemic control after liquid breakfast in patients with IDDM or NIDDM. I don't believe anywhere in here they told you what those acronyms are supposed to mean, which you are. So, but it stands for insulin-dependent diabetes mellitus or non-insulin dependent diabetes mellitus. And what that means is type 1 diabetes and type 2 diabetes. So they tested on both types of diabetes. What they tested for was levels of plasma glucose, just like I did, but they also tested for serum C-peptide. Now, C-peptide is going to be released in the blood anytime insulin is released in the blood. So there's a compound that is a precursor to insulin, and when it is cleaved, making insulin and releasing that into your blood, it is also going to release that C-peptide. So when C-peptide in your blood increases, the insulin has increased as well. So that's their way of measuring insulin, which is probably going to be much more reflective of insulin than just blood glucose like I managed. But again, I was doing this, as kind of a bedroom scientist, so I can't, test my venous blood. I can only test my capillary blood, and I can't test for C-peptide. I can only test for blood glucose. Anyways, they consumed 1,000 milligrams of sucralose, or a cellulose placebo, that was contained in 3 opaque capsules. So you're able to placebo because you're not actually tasting the sucralose. But moving down, they say here that this single test dose was chosen to exceed the estimated daily intake of the sweetener at the 90th percentile. So this was a huge dose of sucralose. It wasn't just a little. They were kind of just like I was trying to do. They were trying to really exaggerate what you were seeing happen in this study, right? Whatever results they were going to see, they wanted to be exaggerated so you can really see whether there's going to be a meaningful difference as normal people will consume sucralose. And here's what we got here in this chart here. They changed it for the two types of diabetes, the type 1 and the type 2. But let's look at these. This column is the glucose, and then they have C-peptide over here. So glucose started with the placebo versus the sucralose. Placebo was 11.9. Sucralose was 10.3. And then same here. Well, for the type 2 diabetics, the glucose level went up. It was 5.2 and then 5.7. But looking at just type 1, I'll play the devil's advocate against my case, right? You see it 11.9 and then goes down to 10.3, right? So again, when the glucose level goes down, it might mean that the insulin was released, making that glucose level go down. And then again, you see the C-peptide, which is reflective of insulin. It starts at 0.03 and then goes up to 0.15. And then for the type 2, it starts at 1.65 and then goes up to 1.86, meaning that it seems like the sucralose kind of did increase the amount of insulin compared to the placebo. You see this small difference. However, in this study, these differences were not statistically significant. So we cannot say with academic integrity that these changes did exist. Some people who choose to spread information will find a study like this and they'll say there was a difference, more insulin was released and stuff like that, versus placebo. And you can say that there was a difference, right? Technically, honestly. However, with academic integrity, we need to consider the strength of these statistical values. We need to consider the p-value. If it's more than 0.05, we can't say it's significant, and that's just the case. And some people don't like that about science, but that's the way it is, and I am totally happy with that. Even in this case, when it, maybe it'll prove me wrong, because I don't really care about being right. I care about knowing what is right. Anyways, they close this study by saying, these results support the conclusion that sucralose consumption does not adversely affect short-term glucose control in individuals with diabetes. So there we go. We had a little bit we got a lot of my study. Thank you guys for joining me there, and a little bit of the real peer-reviewed science as well. So what it seems to say is that, sucralose does have a small effect on your insulin and your blood glucose level. But compared to especially like full sugar alternatives, that sucralose is going to be a lot better for you, even though there may be some insulin response, than the full sugar alternatives. So if you don't really care to consume, like Gatorades and sodas, I'm not saying you should go out and drink artificially sweetened beverages because they're healthy for you. It appears that they're not, right? It's better for you just to avoid them if you don't drink them yet. However, if you are somebody who does really enjoy full sugar sodas, full sugar drinks, like me, they're delicious, I love them, then these zero sugar, these artificially sweetened alternatives do appear like they are going to be very good for you as an alternative, right? So consider that. Thank you for joining me. This has been the Science of Sports Performance.